and run everybody through a virtual lab tour that we've got, so that everyone can have just a bit of a basis of what we've got at ARB. So for over 60 years, ARB has continued to invest in its laboratories, ensuring that we are at the forefront of research, innovation, and pioneering experimentation in bituminous binders, asphalt, and granular materials. Our state-of-the-art, world-class laboratory has been designed with flexible working areas, effective workflows, and unparalleled capacity. The design and flexibility of the laboratories ensure that we can continue to provide construction project support and compliance testing to urban and rural councils, government, state road authorities, industry, consultants, and contractors. ARB's bitumen laboratories specialise in binder compliance and physical testing, as well as polymer modified and crumb rubber binder formulations. Our bitumen laboratory is equipped with a wide variety of equipment required for specification testing, post-construction assessments, new and innovative product development and evaluation, accelerated performance testing, and chemical analysis. ARB has been instrumental in the development of test methods that are changing the way that we test pavement materials. With the increase in emerging technologies and a drive for use of sustainable materials like plastic, wrap, crushed glass, crushed concrete, now more than ever, it's critical to understand the fundamentals and performance characteristics of pavement materials. ARB has an in-depth knowledge of all local and national specifications and how they can be utilised to maximise sustainability and performance outcomes. So what you can see on the screen now is our AUSTRAC equipment, which I can talk about a bit later, which is primarily used for the evaluation of deformation of granular materials, bound and unbound. We've also have an accelerated load facility, which simulates heavy vehicle trafficking on full depth pavement structures and allows for the performance to be evaluated in a very short time compared with trial sites under normal traffic. We've also had some articles published highlighting our research work with sustainable materials for local councils and road authorities. In summary, our laboratory department is highly qualified and can cater for a multitude of services. We're the most well-equipped laboratory in the country and are a one-stop shop for any materials testing and performance needs. So that concludes that, so I'll stop sharing my screen. So that just gives everybody a very general overview of our lab facility and some of our capacities.
Okay, so hopefully we haven't covered too much in that. I was going to ask you what materials you work with, and you mentioned quite a few in that video. Is there anything else, or should we just sort of move on? Have we missed anything in what you spoke about earlier?
No, I suppose the general overview. So we're I'm a part of the sustainability and materials performance business strategic work group, which was founded as a result of some of the work that we've been doing in recycled materials. I am a part of the materials testing and performance portfolio. So that's where we get down to getting the materials in and doing the assessments. Just to give a bit of a list of some of the stuff we've done recently. So we've done crushed glass, chrome rubber in all and any applications, recovered carbon char from tyres, glass, recycled asphalt, granular pavements. We've done crushed concrete, crushed brick, crushed glass, all those sort of applications. And we're doing quite a bit of work at the moment on plastics.
Oh, great. Well, that's certainly a priority for us with the amount of plastic that's generated. And there seems to be quite a few applications for that. Can you talk me through the process of trialling and testing materials?
So one of the things that we've established as part of the group is a way to look at new material assessments, like emerging materials technology. We've got a very general sort of basic flowchart where we look at feasibility trials and what that would entail. Then after that, potentially engineering trials, ad hoc testing, new test method development, specification guidelines and technical reports, and then pilot commercial trials, IP, commercialization, formulation and mix design, and then certification. So one thing that's critical with some of the emerging materials is some of them don't necessarily fit within our existing specifications. So we need to, wherever possible, apply our standard test procedures and processes to evaluate some of these materials. So that would often be looking at, say, a control material, and then looking at a material that has a particular additive in it and looking at that as a basis for comparison.
And are they common tests, the ones that you run, or are you sort of developing new tests?
Well, yeah, so I suppose I would say maybe 90% of what we do are fairly common tests. You know, they're well-established tests where we've got, you know, specifications, you know, locally and across the country, where performance outcomes are known. But there are obviously, you know, with some of the materials, there are some limitations. So plastics, for example, is a key one. So, you know, we can certainly add plastic into the bitumen to create asphalt. We can certainly add it in as a dry process to the hot aggregate materials to make an asphalt and do all the standard type testing, but that doesn't give us any information about microplastics. So what's leaching out of it, things like that. So there are some times where we need to, you know, we're doing everything as our stock standard, as our base comparison, but then there's a particular concern about a material, and we need to work out, you know, is there a way that we can actually extract the microplastics from a asphalt mixture and assess them for, you know, the amount that we're getting out, whether they're coming out at all, things like that.
That's interesting. So talking about the leaching, what are you actually testing for in that whole regime? Are there one or two things? Does it vary with different materials? What are you looking for?
Yeah, so leaching specifically as far as the plastic goes, we're looking at how much of that microplastic is actually coming out of, say, the asphalt binder mixtures, and potentially getting into our waterways, because, you know, as you may or may not be aware, but you know, microplastics are everywhere. We breathe them, we eat them, we drink them. They're just absolutely everywhere. And so when we put them in our road network, you know, we've got traffic that goes over the top of them, weather events, things like that, that can all potentially lead to some breakdown of that material. And we want to make sure that when that happens, that it's not detrimental to the environment.
Absolutely, yeah. That's sort of frightening. I hadn't really thought of it in that space. So, yeah. I mean, there's a huge range of products coming on the market, and we're always pushing to get more because it's a world that we need to live in. Yes. What is the normal pathway to get to a testing stage?
So I suppose that's a very good question. I suppose one of the interesting things is, you know, we've had quite a lot of development in recycled materials, you know, spurred on by the fact that, you know, we couldn't export a lot of our materials like we used to. So we had to look inwards, like how can we use these materials? And a lot of the traditional specifications didn't really have the ability to able to accommodate that. So, you know, we need to have a look at those materials, see how they interact, see what their base level properties are, seeing what applications they can be used in. One interesting project that we're looking at as well at the moment is recycled paint. So we're looking at, you know, you've probably heard some ads on the TV, you may have seen some billboards around the place, but paint back, yeah. So effectively what we're looking at is we're looking at that product and how can we use that product in and around the road network.
Oh,
so there are obviously, you know, some challenges with doing that, but there are definitely some ways that you can use that material to put it back into the road. You know, traditionally it might not work well, say, as an asphalt or, you know, as a binder additive, but there are other applications where that can be suitable. So it's all about getting those materials in, trying to establish a program of works where we're applying all of our knowledge and our expertise with, you know, local and international work, and that's with that paint back one. That's a world first. So there's no one anywhere in the world that's doing that sort of work or research. So yeah, that's the sort of thing that we look at.
Yeah, that's sort of a huge problem too. So broader than that, how are you applying the testing of materials in the real world? You're in a lab, which looks amazing, but ultimately the application for most people here on this call is, you know, how do we put it into projects and how do we test it and how do we know that it's going to work?
Yeah, look, and that's the billion-dollar question. Like, you can do something in a lab. How can that be comparable to what happens in the field? So ultimately, the laboratories are used as a way to fine-tune products, to look at where they will work, to do all the experimentation beforehand and land potentially on a couple of options. Then once that we've landed on those couple of options, then it's like full-scale type trial sites. So we can have things like testing under the accelerated load facility, which can generate a lot of trafficking over a short period of time, and that involves setting up a full pavement, or we can create a trial site. So this can be, we've done quite a lot recently with Sustainability Victoria and the Department of Transport. We've done crumb rubber trials and some high glass trials that we just did for as part of a project for SV and Brimbank City Council. So the reality is it's got to get out of the labs, and you've got to have those trial sites set up to see performance. But I suppose the key thing with the laboratory experimentation is we've got specifications and standards that we're comparing the information to. So you're not, in effect, just going out there blindly knowing that something is going to fail. But there might be a case where you want to potentially push the boundaries. So some work for a local city council in New South Wales that were looking at recycled glass in their granular materials. They were putting in about 10%, but weren't really sure whether or not that was okay. So we were able to do an assessment on the deformation characteristics using Austrac, which is the only operational piece of equipment in the country that can do what it does. And what we effectively determined was they could put up to about 40% recycled glass into their granular pavements without any detrimental performance on that material. So that's massive. The next challenge that they, of course, faced was that they didn't have the material stocks on the ground to do 40%. So they could take it up to 40% if they wanted to, but they were sort of, the most they could probably get out of that was maybe another 5 to sort of 10% before they started to run their glass stocks low. So as time progresses and we've got more stocks on the ground, we'll be able to do it. And that's a key factor that we think about with our sustainability materials. It's how much is there, is there a demand for it? But you don't have to have tens of thousands of tons on the ground. You can have for what we do, you could have potentially a couple of tons on the ground that we could then do assessments based on that, which can then inform you to processes that you might need to do, or upscaling plants, things like that. So just giving you that sort of that confidence that you're taking the right step and that you're heading in the right direction.
Okay, that's great. Can you hear me?
I can certainly hear you.
Yeah. Okay. Great. Sorry. Yeah, so that was, so then how do you find the trial sites? How do you find a site to trial these materials?
Yeah, so that's one of the very interesting ones as well. Normally what happens is we look at either new construction that's happening, where we can potentially look at modifying some of the construction layers and the materials, or when we've got rehabilitation projects where we've got something that needs to be rehabilitated, potentially profiled out and completely reconstructed, and they're really good sites because then we effectively get a time equals 0 for that sort of material. And look, I suppose the other thing is with some of what the field trials are, it takes time for these materials to to age and to deform and to potentially break apart or whatever. So trial sites are really a really good way to get that material out, but the time before you can see if that performs could be sort of 5, 6, 7 odd years, and by then the technologies may be changed. But that's where sort of doing some of that laboratory experimentation is good, because we can accelerate some of those processes to see what happens or what could potentially happen in 5 and 10 and plus years.
Yeah, that certainly makes sense. So do projects propose trials to you? Do they, if they'd like to trial something on their on the work that they're doing in roads or rail or building bridges, would they come to you and propose that they'd like to trial a material? Is that how it works?
That's how it works some of the time, but the majority of the time, how it works is, we need somebody that's got the technical expertise that understand the materials, what happens locally and internationally. So a number of those programs that we've been key in establishing, the types of material that we want to look at, the testing frameworks that we want to do for the materials, and subsequent to construction, looking at all of the different, the revisits of site. So we can certainly have materials that somebody wants to trial, and in some cases, a company comes to us with the material, and they don't have a road that they can do it on, they don't have a trial site that they can use, but they've got their own car parks. They've got heavy traffic coming in, going out. So you can actually use your own sites as little steps into seeing performance.
Okay, that's great. So what sort of timeframes, what testing is required to get materials, products, designs to the stage where you are reforming standards and specifications, updating or introducing? And what timeframes are sort of attached to those? We've got one question in, but we've still got a couple of minutes we'll chat before we check into the questions.
Okay, yeah, so it's a pretty good question. I think traditionally, up until recently, everything has sort of taken quite a long time to get, materials tested and assessed and things like that. But we're certainly, depending upon the material, it can be a quick process, and we would normally, have a staged approach to materials assessment. So we would know potentially how a particular material would perform and what are the key criteria for, progressing to the next step. So, you might do some bitumen testing of a, product that you've added into your bitumen, and you might find that it fails one or two of the tests. So that's it. The tests stop there, and then we reformulate, we move from there. Asphalt mix designs, depending upon availability to, say, current thick road spec, you're probably looking at between sort of a 2 to sort of 5-ish week turnaround. The key thing is getting everybody involved, and I think that's probably where we've been quite fortunate recently. Is a lot of NTIA and ecologic projects have really been pushing those boundaries and getting things out there that traditionally might take a bit of a longer process to do. So yeah, and if there is a really desperate need, like we had a desperate need, I think probably about 2 or 3 years ago now, for a local crumb rubber specification for low volume traffic roads. So we worked quite closely with Department of Transport Victoria. We got a framework in, we did some laboratory testing, we got a specification out really quickly. So within sort of, say 6 to 8 months. Wow. And, that sort of stuff hadn't happened before. So, it is that process that can happen. It just, depending upon the application, it does take some time.
Yeah, I'll go to Daniel's question. Noting your comments about the time that trials can take to see results, how do you recommend asset owners assess risk? A conservative approach would mean that we wait until we're confident in the results before progressing, but we know from the climate science that we don't necessarily have that time.
Yeah, so that's a really, really interesting question, and I suppose that's the challenge that we've got from a risk point of view. We might be doing all the laboratory testing, and we've got a trial site, and we say, yep, okay, well, this, traditionally we would only put, say, 5% glass in a mix, and we're putting, 25% in. The time that it would take potentially for that to fail, you might be taking a big risk, and you might take that big risk for, say, 2 to 5 years and just put it stock standard everywhere. But then at the 6-year mark, your roads start sort of falling apart and failing. So there isn't definitely an element of risk. I suppose the key is mitigating that risk as best as you possibly can, by doing sort of, follow-up experimentations. You can always go out and take core samples, and, I suppose in some cases that's not ideal when you've got, a granular pavement and on top of an asphalt. So, you might have to go pretty deep in, but there are processes that you can do that can take you back and give you those little snapshots of where you're at in that point in time.
Oh, great. Okay, next we've got 3 questions now. So what is ARB's and Vic Road's experience with evaluating coal combustion products for use in embankment construction? That's a really different one. But
Yes.
yeah.
Yes, I'm not 100% across that sort of thing. I'd have to potentially defer to other areas within this sustainability and materials performance group. It is something that I believe that we've looked at, but I can't say with any degree of certainty. We do have, part of that group also looks at, environmental assessments and things like that, carbon offset emission calculators and that. So yeah, so unfortunately I can't really answer that question. It's a bit out of my my area.
Well, that's fine. We'll take that on notice and come back to Peter on
That's
that
right.
one. Yep. Damien's asking, does recycled material additives like plastic and crumb rubber impact ability to reclaim, to reclaim, reuse asphalts or components like aggregates? Are additives like plastic and rubber also reused after reclaiming aggregates? And is there performance losses in recycled material components? Did you get all of that?
Sure did.
Yeah.
Yep. So I suppose we'll sort of break it down a little bit. So yeah, so it's a very good point that you raised there. The key thing is, our recycled materials are going to potentially be recycled multiple times. We don't, I know, say over in Europe, they have a pretty tight control over some of their road networks. So if you're going out to a job to profile out a job, they would know what's in that mix. Now, we wouldn't necessarily know that. So, that in itself is quite challenging because you might, and there would potentially be mixes out there that are using, say, 20 and 30% recycled asphalt materials that have potentially been there for 20 years that have been profiled out and put in a job and goes back in and profiled out. So that's one thing that is quite difficult. And I suppose the key thing is all about the consistency of that product. So part of the evaluations that we do is we look at consistency of supply. So, so that's one thing that you can do. And I suppose the other part of the question, which was the tail end. So do you want to
are additives like plastic, rubber and rubber also reused after reclaiming aggregates? And is there performance losses in recycled material components?
It depends on the material itself. I suppose sometimes you could see some detrimental performance by using some recycled materials, but that all comes down to your due diligence at the start to do that assessment to make sure that those materials can actually, that they're not going to cause you any problems. And just say on the recycled asphalt, that's, any asphalt plant, it's not just a 14 mil dense graded asphalt with C320 binder in it. You could have all of the binders. You could have polymer modified binders, low wraps, high wraps. That is just a big soup of every type of mix that you can possibly get. But there are consistencies that you get from that particular process where they have processes where they're looking at the characteristics of that product.
Interesting. Well, that sort of brings me to a question. There are so many there's such a range of plastics, polypropylene or whatever it's called. Do you have new tests for plastics? Do you continue to develop those? How does that sort of work?
Yeah, so that's so traditionally we've got all of our tests that we would commonly do in Australia, which can be linked to field performance, like some of the tests, like viscosity is how easy the binder is going to pump, consistency is, relative to deformation. So we'd have all of our standard type tests, but I think with these sorts of materials, we have to cast our net a lot wider than just what we do locally. So we need to look at, and we were looking at, American and European test methods that are a little bit different to ours, because in some cases they're sort of a little bit more advanced than what we are. So we're looking to those examples of testing to able to inform us a little bit more than what we would already do. And there's a potential that there isn't something that's going to give us the right answer or an answer that we want, and then it's a matter about modifying a process or a piece of equipment, or looking at something that was traditionally used for a different application and seeing how you can apply it for those types of materials.
So it's a constant evolution, isn't it, really, with all the new materials coming on board?
Yeah, absolutely. And that's where we've been pretty lucky, up until probably, sort of 2-3 years ago. There really wasn't much plastic, but there was a lot of recycled asphalt and a tiny bit of glass. But in that short period of time, there's lots of glass, lots of wrap. We're talking about plastics, talking about crumb rubbers of different types of processes to get crumb rubber as well. So it's going exponentially as far as the materials go, and the key part is trying to stay ahead of that, or to keep up at the same level with that. And that's where sort of, some of the bigger companies have, facilities, not obviously the same size and with the same capacity as mine, but still they've got that ability to do that pre-testing to develop all the tests.
We're very close, but I just did want to, did you have any last words of wisdom before we quickly flick to the final screen?
Yeah, so I suppose if any of my years in this sort of industry has taught me anything, we need to be making sure that you are getting as much information as what you can up front, making sure that what you're asking for, what you're specifying is reasonable, that there's things that you can test on an asphalt and a bitumen as it's being supplied to you. You can get samples, you can do some testing, or you don't have to do some testing. But if there's a failure on that road or that construction job, you don't have anything to go back to. And it can be quite challenging to establish what the problem was originally. It could be that the material itself had a flaw. The bitumen didn't meet the specification, and that could be why it's failed. So that would be the big thing that I would say. It would just make everybody's lives a lot easier if you had that baseline to go back to, and we certainly don't see it enough.
I'm going to squeeze this last question in from Peter again. What's your experience with recycled crushed concrete in respect to using as drainage aggregate? Are there any issues for environmental risk with water discharge? I will just say our next session on the 22nd of April, we are talking about some trench backfill, but I'll leave you to answer that question as well.
Yeah, so again, that's an area that's a little bit out of our expertise at this point in time. We're mainly sort of focusing on the granular materials and the road structure. But obviously, though, these types of materials are being used in all sorts of applications. And I'm sure there would be somebody that would be able to provide you with a bit more of an update or an answer to that question.
Great. Thank you so much, Shannon. That was really interesting. And it's certainly an area that we all really need to think about because we're wanting to evolve.
Yes.
We will get back to Peter on his question, and I'll just, we won't be running a session next Friday because of Easter. We will come back on the 22nd, and we are talking to Ernie Gemling from Victoria University and Shalini Trinka about recycled backfill materials. So that should be quite an interesting subject. Hopefully, shoot your questions throughout the session and we'll get to them at the end. And if you have anything, happy for you to email the Ecologic inbox at ecologic@roadprojects.vic.gov.au. And if you're not aware, Ecologic now has a website. And if you just Google ecologic.vic.gov.au, you'll get there. It's on the Big Build website. But yes, just Google ecologic.vic.gov.au and it'll take you to our new website, which we're very proud of. So thanks once again, Shannon, and thank you everyone for attending.
Thanks, Cheryl.
Thank you. Bye.